Moving now into what is called the axial limbic brain. This is subcortical parts of the brain involved in autonomic functioning and emotion. This includes the autonomic nervous system, which we're going to talk about, the limbic system, hypothalamus, and the reticular activating system, which we've already discussed to some degree. So when we say the axial limbic brain or the axial limbic system, we're talking about autonomic nervous system, limbic system, hypothalamus, reticular formation, and all these things are integrated and acting together to control basic physiological autonomic functions and to do so in symphony with our emotional demands. So if I'm going to be attacked by a saber tooth, then my body needs to respond to that fear that saber tooth is inspired in me. And this is the realm of the axial limbic system. So let's back up and start with the peripheral nervous system. We've already talked about this. We've already gone through this, but to reiterate, you have the nervous system of the human nervous system, and that's divided into central and peripheral. And then we talked about the peripheral nervous system being divided into the somatic and the autonomic. The somatic nervous system are those afferent and efferent pathways that innervate skeletal muscles. So these are the muscles of volitional movement. These are your striated muscles. And then you have your autonomic nervous system. And these are those afferent and efferent nerves which innervate organs and glands that control vegetative functioning, visceral functions, your smooth muscle of your digestive tract, cardiac muscle. We can further divide the autonomic nervous system into the sympathetic and parasympathetic, meaning that we have pathways within the autonomic nervous system that are responsible for turning on our fight or flight reflex, which when that happens, I'm going to be attacked by, we'll say, a saber tooth. My blood vessels are going to constrict, which elevates my blood pressure a little bit. My heart is going to start pumping faster. At the same time, my cells are going to be dumping glucose into my bloodstream, adrenaline for fast energy. My pupils are going to dilate, so I take in as much light as possible to all these things to increase my chances of survival. And let's say I get away from the saber tooth, I make it to my cave, I roll the stone in front. I can't live the rest of my life in that hyperactive state. My body needs to come down. It's the parasympathetic system that engages and pulls you back from the fight or flight state that you're in. So your parasympathetic system slows everything back down. Your body goes more into energy conservation than energy expenditure as quickly as possible. If we look at the anatomical differences in sympathetic and parasympathetic, let's see if I can. So the green wires over here, these are our sympathetic nervous system. So you can see that no single wire is very long, no single nerve is very long. They're connected. There's a lot of interconnectivity. And this is good because if a tiger jumps out at you, you want your body to react be able to react as quickly as possible. You want to be able to turn on that fight or flight reflex instantaneously. So you don't want a nerve signal to have to travel down a very long pathway from point A to point B. You want it to take as short a path as is possible. So the sympathetic system, you can see that its nerves are much shorter, its wires are much shorter than the sympathetic. The parasympathetic. Looking at the parasympathetic system here, especially this particular nerve, you can see that it's very long. So it's going to take a while much longer for a nerve signal to get from the brainstem down to the liver and gallbladder than say it is for a nerve signal to get from the spinal cord right out to the heart or the lungs or the stomach or the eyes. But that's fine, because if you've made it to safety, then your sympathetic system has worked. You have time, your body has time to bring itself down. So your parasympathetic system is never really in a rush. So if you've made it to safety, it's got time to do what it needs to do. And the term ganglia or ganglia cluster, this is a bunch of nerve cells. So when we see the ganglia here, this is sort of where all nerves meet and branch off in different directions. And you can think of it as like how electricity moves through a power supply. So electricity signal comes in here, and from the power supply, it's able to simultaneously move out along multiple wires, and that's the same with the ganglia clusters. So even if you went in and cut a few of these wires down here between the spinal cord and the ganglia, those signals that are generated along other nerves coming from the spinal cord will be able to get down and then out to the targets. So that's just some anatomical differences between the sympathetic and parasympathetic. So sympathetic is fight or flight, parasympathetic is relaxing. So this is a sympathetic situation, parasympathetic